Assignment 3, Part 6. Our first topic is domain and range from a graph of a continuous function. All right, so they want the domain and range using interval notation. So I kind of think about boxing the function in. Okay. So the domain are the x values, so it's left, right. So I think of my box here, the furthest left that my box goes is -2. And it's an open circle. So whenever we see an open circle and there's nothing else with it, because I'll show you that later. Sometimes there's some exceptions to this open circle, but if you look at this open circle and you look at the -2, the x value, there's nothing else there. So the domain, we're going to start with a parenthesis, -2. So that's the left side of our box. The right side goes to the number 5, and it's an open circle. So we're going to go -2, 5, both with parentheses. And for this problem, the range, the y values, because they're open circles at the end, are also going to have all parentheses. All right, so our range, you start with the lowest point. The lowest point of our graph, which I use at the bottom of the box, is -4. And the top of the box, the highest y value on this graph, is approaching 3 because there's an open circle. So it's 3 with a parenthesis. Okay. So that was number 1. Okay. So I boxed it in. So remember, domain are your x values. Those are your x values there. So I look at it as left and right. Range are your y values. I look at that as, bottom and top, or up and down, down and up. Okay. You should put these in order. I'm not sure if Alex will take it out of order. Just put it in order, numerical order. Let's take a look at another problem. All right, this one has the exception. It's a little interesting. So you don't have to do this, but there's my top, right? There is my right side. There is my bottom. And there is the left side. Okay, so just like before, the domain. The range here has the little exception. So the domain is left to right, an open circle. So we're at -1. So we're going to start with a parenthesis, -1. And we're going to go all the way to the right, 1, 2, 3. It looks like it's 4, but there's an open circle. So we're going to use a parenthesis. Now here is the tricky part. So it looks like our curve pretty much hits -4. It's going to be a nice number. So I know probably because I zoomed in, it looks a little worse. Looks like there's a little space there, but it's going to hit -4. So the bottom's -4. Whenever you have a piece of the graph, it's considered a closed circle. So like these are infinitely many little dots that are closed. All right, so our bottom piece is -4. It's part of the line, so we use a bracket. And the top here, we don't care about this piece here because it's matched over here. So you might say, oh, we don't have 0 here, but it is here. So as long as it's somewhere, we're going to count it. So we did the bottom. Now what we do is figure out the top. So we don't really care about this one. So the top is just like our box, looks like it's 5. But the top piece at 5, it has an open circle. So what do we use? We use a parenthesis. So part of a line is considered a bracket. It's included. All these little dots on the line are included. All right, so that was number 2. Okay, if you want, pause it, try this problem. Only thing I want to point out here, this is closed, this is open. So if you want to pause it, try it, go ahead. I'm going to continue with the problem. So the domain, the furthest left is -3 with a closed dot. So -3 with a bracket. And how far right do we go? 2. You can make the box if you want. 2. And it's open circle, so we're going parenthesis. And range. The bottom is -4 with a filled in dot, so bracket -4. And the top of this graph is at 3 with an open circle. So we're going to go 3 with a parenthesis. All right, so for the domain, -3, this was filled in. You got a bracket. For range, this was -4. The bottom filled in, so we got a bracket. This was open, so parenthesis, parenthesis. Okay, now we're going to look at the domain and range of a quadratic function using interval notation again. And that's what you usually use in pre-calc and calculus, so it's good to use it. All right, so you have to use your imagination. I'm going to draw over this a little bit. Pretend this is going out and down forever. I'm just embellishing a little bit, exaggerating. All right, pretend it's going out and down forever. So for all these quadratics, the domain will be from -infinity to infinity. Because when you have a quadratic, you're allowed to plug in any x value. But you can see the graph here. It goes down and out forever. Let me get rid of that so I don't throw people off. Okay, so you have to use your imagination a little bit. So down and out forever. So domains -infinity to infinity. Now, it's going down forever, but we definitely have a top here. So our top is 4. Okay, so that's just 4 there. So for our range, it goes down forever. So we go with -infinity. And the top of it's 4, and it's part of our curve, so we're going to use a bracket. And remember, we always, always, always use parentheses with infinities. Okay. So pretty much for this whole section, your quadratic will always be -infinity to infinity. Or maybe, I didn't look on Alex, you might be able to select all reals. They want interval notation, so I bet they want this. But if this is a clickable option, then fine. All reals. Everything works in a quadratic. All right, let's take a look at another problem. Okay, here's a problem number 2. If you want to try it, go ahead, pause the video. I'm going to continue with the answer. So once again, domain, -infinity to infinity, because this goes up and out forever. Okay, the range, the lowest point here is -4. And then remember, it goes up forever. So it goes to infinity, and we always use a parenthesis. All right. And that concludes this video.